The circle is as small as a coin. The triangle is as large as a pyramid. The square is about the size of a floor tile. Now we add exactly 1 meter to the perimeter of each shape. Naturally, larger similar shapes appear. Around each shape, a uniform gap forms. If a cat were to walk through that gap, which shape would create the widest space? You might guess the small circle creates the largest gap. Because it is so small, adding 1 meter feels like it should matter more. But is that intuition correct? Consider a circle with radius r. Its perimeter c is 2 pi r. If we increase the perimeter by 1 meter, the new perimeter c prime becomes 2 pi r plus 1. Let the increase in the radius be delta r. Then the new perimeter is 2 pi times r plus delta r. So set these equal. Delta r equals 1 over 2 pi, approximately 15.9 centimeters. But here's the surprising part. The value of delta r does not depend on r at all. Whether the circle is as small as a coin or as large as the Earth, the increase is always the same, about 15.9 centimeters, completely against our intuition. Now, let's look at a square. Let the side length be s. Its perimeter p is 4s. After adding 1 meter, the new perimeter p prime is 4s plus 1. Let d be the outward gap added uniformly to each side. So, the new perimeter can be written as 4s plus 80. Set this equal to 4s plus 1. D equals 1/8. That is about 12.5 centimeters. Once again, the side length s does not appear in the result. No matter how large the square is, the added gap is always the same. But it is smaller than the circle's gap. What about an equilateral triangle? Let the side length be t. Its perimeter L is 3t. After adding 1 meter, the new perimeter L prime is 3t plus 1. When we expand the triangle, besides the original 3 sides, 2 new segments appear at each vertex, for a total of 6 identical segments. Let's focus on one of the triangles. Since this angle is 90 degrees, this is the right triangle. Let the length of this side be h. Since this angle is 60 degrees, this is 30 degrees. Take the tangent 30 degrees. X equals root 3h. There are 6 such segments. Add them to the original perimeter. This must equal the new perimeter, 3t plus 1. So, h equals 1 over 6 root 3, approximately 9.6 centimeters. Once again, the result is independent of the triangle's sides. In all 3 shapes, these gaps are measured in the direction perpendicular to the boundary, the analog of the radius. When 1 meter is added to the perimeter, the circle gains the largest gap, the square gains less, and the equilateral triangle gains the least. However, none of these values depend on the size of the shape. As the number of sides increases, the gap grows larger, but not without limit. That limit is the circle. Perhaps the circle is really the ultimate form of the regular polygons. In the end, the shape where the cat can walk most comfortably turns out to be the circle. This is the 1 meter perimeter paradox. It doesn't stop here. It continues.